Hi, Mr. Nickerson here. Today we're going to go over 9-2, factoring using the distributive property. If you'd like to take out your notes, and we'll begin. We're going to start by always doing the GCF first. So our first step, if you want to have steps for this, is we're going to find the GCF. You look at your numbers, you got 12x squared, you got 16x. So our GCF would be the GCF of 12 and 16, which if you got to do it out, you can, but we know it's going to be 4. And then the GCF of the variables. They both have x in common, so it's going to be the lowest power, x. Once you have the GCF, you rewrite it as 4x, or whatever the GCF is out front, and you have a parenthesis. And you just need to fill in, this time in 2 spots, what numbers or what variables we have to multiply by such that we'll get, if we distributed, 12x squared plus 16x. So we think we got 4x times what gives us 12x squared? It's 3x. Because 4 times 3 is 12. X times x is x squared. And we can do the same process again. 4x times what gives us 16x, and it's going to be 4. 4 times 4, 16. There is an x here. I don't need one there because I only need x to the first. We successfully did the first problem. So we go to example B. Same exact steps. We start off finding our GCF. GCF of 15 and 25, 5. GCF of x squared next to the third, x squared. We set our parenthesis. And then we begin with our GCF factor. Now from here, well, we think 5x squared times what gives us 15x squared? It's going to be 3. We keep going. 5x squared times what will give us 25x squared? Well, 5 times negative 5 is the 25. I need x to the third, so I need that additional x. The last one, letter C. We see we got 3 terms. So, just like we talked about yesterday, was that when there was 3 terms, we will do the same process, but we'll have to compare it to all 3. So 18, 12, and 9, the GCF of those would be 3. They have x, y in common on them, all 3. So we want the lowest power, so we got x1, y1. And now we repeat the same process but for 3 terms. So 3 times what gives me 18? Well, it's 6. X times what gives me x? Oh, it's 1, so I don't need to write times 1. And then I got y times what gives me y squared? A y. We know it's plus. And we do the same process again. 3 times what gives us 12? 4. X times what gives us x squared? X. I've got the y already. I don't need it there. Another plus. And then finally, you can see on the last one, 3 times the 3. And I don't need the x, I don't need the y, because there is no powers higher than 1. And we successfully completed the problem. The first example that you were trying on your own, you can see we took out the GCF, and then after taking out the GCF of 12x, we got 2x minus 3 in the left-hand side. Same. All right, let's go to example 2 here. And you can see, pull out the 27x squared. After that, we're left with x squared plus 2 inside. Sometimes people forget that when you pull out that 27 and the x squared, that when you have the 54, there's still the 2 in there. Some people forget about if there's a plus 2 or plus 1, etc. The last one, as you look, you're going to see that you take out 6xy squared, and then you have 2x plus 4 minus 5y squared left inside. Okay, so let's go over factor by grouping. For factor by grouping, you see the big thing here, we got 4 terms. And how we start these is, you group the first 2 and the last 2 terms. Then, we're going to do GCF factoring. by distributive property for both parentheses. So we start 4 and 8, we got 4. They both have b in common, so we'll take the b, and we're left with a plus 2 inside. We repeat the process in the second parenthesis. GCF factoring. You pull out the 3. Since it's positive, I pull out a positive 3. A plus 2. You know you've done this correctly if you have a match of your parentheses. Inside the parentheses, we got a perfect match. So all we're left with is what's in front and one of our duplicate parentheses. And this you can see, for some of you, it's like your double distribution or your FOIL method that we've seen in the past. Let's take a look at the second example. Letter E. So we start off the same way. Group the first, group the last. Pull our GCF. GCF is going to be 5x, and we're going to be left with 7 minus y. Go to our second parenthesis. They've got 3 in common, and we've got y minus 7. We see that we're extremely close in having a perfect match. That those parentheses are almost identical, but they have the opposite signs. So what we need to do is one of two things. Instead of pulling out a 5x or a positive 3, we're going to plot a negative. And when we pull out the negative, that would make the y positive and the 7 negative. So what I would do here is pull out a negative 5. That turns from negative to positive. That becomes a negative. And now we have the exact match. So we can say negative 5x plus 3 and y minus 7. Could I put negative 7 plus y? Yes. But typically you'll see the variable be put first. The last one, letter F. This type of problem we're actually going to see a lot of, okay, in a couple classes. So you start this off, same process. Group the first 2, group the last 2. Do GCF factoring. If you do the GCF factoring, you're going to pull out an x, and you're left with 7x plus 1. Same process happens again. GCF factoring, pull out a 3, 7x plus 1. And then you see we got our match. So x plus 3 and 7x plus 1. Alright, let's look at the first example here, example 4. When you start, group the first 2 terms, group the last 2 terms, take their GCFs out, and this time we see that they're not a match, okay? That they're not the identical parentheses inside. Once you see that, we know it's called prime. And I wanted to show you that first on the notes tonight, and then you'll see some more of those tomorrow in class. It happens. Example 5. You group your first 2, group your last 2, 3x out front, 5 minus 1y plus 4y minus 5. You see 5 minus y and y minus 5 are very close to being the same. So I decided to pull a negative 3x out instead, or you could have pulled out, made the negative a 4, but I chose to do the negative 3x and then switch the sign. So 5 became negative, y became positive, and then I had my match to write my answer. On the last one, you can see, pull your GCFs out, and you see on this one is, we'll learn more about this in class, but when you go to the second parenthesis, you pull out a 7, it wouldn't be a perfect match. So to make it be a perfect match, pull out a negative 7. A lot of times we call that the hot spot. Okay, and the hot spot, let me zoom right in on it. When you have a negative in that third term, that's going to be a big key concept that we talk about next week. Okay? Okay, let's look at the zero product property. And what the zero product property is that once something is factored, we can set the factors equal to 0 and solve. When we get those answers, they're either called roots, or called zeros, or called solutions even. So all we're going to do, once it's factored, is set our parentheses, set our factors equal to 0 and solve. X plus 3 equals 0, x equals negative 3. X minus 5 equals 0, x equals 5. And that's it. Not the most difficult thing, but we need to make sure these ones I know are already factored, so they don't take the most time. Let's look. Letter H. If we do letter H real quick, we will see that set each parenthesis equal to 0. We'll solve it same exact way. So 2d minus 1 equals 0. 3d plus 2 equals 0. 2d equals 1. So d equals 1/2. Minus the 2. 3d equals negative 2. Divide by 3. And d equals negative 2/3. And we've just found our roots. Alright, let's look at the last two examples you tried on the first page. And you can see here they're already factored, so we set the factors equal to 0, we solve, and we get x equals negative 1, x equals 2. On the second one here, same thing, set them equal to 0, solve, x equals negative 3 over 5, excuse me. Alright, here we go. On the second one, you can see we get x equals negative 3/5, x equals 3. Alright. Last thing we'll talk about is putting this all together. Factoring using the distributive property, GCF factor, and using the zero product property rule. To start this off, we're going to look at the first example up here. 3x squared equals negative 18x. Well, we need to make sure if we're going to factor anything, and it's an equation, it's got to be equal to 0. So we got to make that equal to 0. I'm going to decide to move this over to this side. So I get 3x squared minus 18x equals 0. And now we're going to do our GCF factoring. What's the GCF? Well, 3x, x minus 6. And now we'll use the zero product property. This time, though, we don't have two parentheses. But it's okay. We set our factors equal to 0. So we set what's in front, 3x equal to 0, and we solve and we get x equals 0. And we set x minus 6 equal to 0, and we get x is 6. And we've just found our two answers. If you'd like to at the end, you can check it. If you got time, take a second, and you can check it. Alright, let's look at the last ones that you had to try on your own. First thing, get it equal to 0. After that, GCF factoring. Then set your products equal to 0. Solve them, you get your two answers. As you can see, very similar on the next one. I moved the 5x over, got it equal to 0. GCF factoring. Set my factors equal to 0. Solved, got my answers. On the next one, I decided to move my x over the other side. I like to have my x squared go first, but you don't have to. Just wanted to show it for variation. But when you do so, moving it over, set equal to 0, GCF factoring, set your factors equal to 0, you get your answer. You would get the same answer had you moved 16x squared over, you would have had the same answer. Same thing on the last one here. I decided to move that 6x over, even though the x squared's not first this time, just to show some variation. Then do my GCF factoring. I pulled the negative out, didn't have to, but either way you would have done it. If you pulled out 4 or negative 4, for the x, you still would have had the same answer in the last step of x equals negative 1/3 and x equals 0.